I want to talk about 120 volt sub panels for a minute, and I just kind of want to get your guys' feedback on what you've seen before. As far as I'm aware, 120 volt sub panels aren't really a thing, and there's a couple different reasons why it's not really a good idea to set up a 120 volt sub panel. I'll tell you guys those reasons in just a minute, but for now I just want to show you how you can use a 240 volt panel as a 120 volt panel. The way electrical panels are designed, every other breaker pulls from every other leg of the 240 volts. When you take this off of here, we can see what's going on. I did not wire this panel myself. This is just an example of a 120 volt panel that is currently set up. Albeit this is really a 240 volt panel being used as a 120 volt panel, and I'll explain that here. So let's go through it. Here at the top we have a piece of 12-2 with ground cable that is feeding this panel. This is a 120 volt circuit that is being fed by a 20 amp breaker back in the main panel in the house. This wire comes down into the box, and you can see once it gets stripped back over here that we have a bare ground wire, a black hot wire, and a white neutral wire. The ground wire goes over to a dedicated ground bar here in the corner. The neutral goes to our neutral bus right here, and then our hot wire goes to one of the two spots where your 240 volt legs would normally land. So we've got it landing over here on this leg. And you can see back in here that by that being connected, that actually makes a connection to every other space inside of this panel. So you can see this space right there is connected to this leg. That space right there is connected to the leg that leads over to this terminal over here, and so on and so forth. It's just that we don't have a second leg of 120 volts coming into this panel. So since every other slot is dead in this particular panel, we would technically only have room for 3 circuits. And we've got 2 already in use, so we have 1 more that's available. There is a way that we can make all 6 of these slots work that we'll talk about in a minute, but first I have a quick question for you guys. For those of you that are electricians or electrical inspectors, what do you guys think about this particular setup? Does this seem like it has a lot of reasons why it's a terrible idea or not? Comment down below and let me know what you think about it. As it's currently set up, I personally don't see any issues with this being any sort of a safety hazard. It's operating the same as it would have were it a 240 volt panel with all of the proper safety considerations and connections being made, which let's talk through those here really quick. First of all, we do have a grounding electrode conductor coming up and connecting to our ground bar in the back of the panel, just like it's supposed to. Our ground wire from our circuit that's supplying this box is also properly connected to the ground bar. The ground bar is separated from the neutral bar, which is something that you're supposed to do with sub panels. So if there were to be a dead short from, say, one of these black wires here to the frame of this panel, it would trip using the effective ground fault current path, which is going through the frame of this panel to that ground bar and then onto the ground wire that makes its way back ultimately to the main panel. If you find this content to be interesting, take a second, hit that subscribe button, and turn on notifications. I'd really love to have you as part of the community. And for those of you who aren't already aware, this is a dual function breaker that's both ground fault and arc fault. And this one is just a ground fault breaker. So all of the circuits in this garage are protected by ground fault, and then one of them is protected by arc fault. Arc fault is optional in garages, but ground fault is required for any receptacles. So this is a pretty safe and quality installation, albeit it's not the most organized, but it really doesn't have any glaring safety issues that I can see. So let me know if you saw anything that is a terrible safety consideration. Alright, the next thing I want to talk about is how we can actually make all 6 of the spaces in this panel work on a 120 volt circuit. And all that we would have to do in order to make that happen is to put a jumper from here, from this leg that's currently connected, over to this other leg over here. And that would cause there to be 120 volts available on every one of these slots We just wouldn't have 240 volts available. Now, I do not recommend doing that because it is unclear what is going on when you are looking at a panel. Every other slot should be coming from every other leg of 240 volts. By leaving just one connected, that's not going to make somebody think that, oh hey, there's two slots available right here, I can pull 240 volts out of this panel. If they were to try doing that, they would discover that one of the legs is dead, and then they would realize, oh, this is just being fed by 120 volts. The other reason why it's a bad idea to set up 120 volt panels like this is that you're basically putting all of the load on one leg of your electrical system. Your transformer from end to end measures 240 volts for standard residential transformers. From one end to the middle of the transformer is what you get 120 volts from, and that goes from both ends to the middle. Your neutral is derived from the center tap of the transformer. So if you were to set up your entire house to be only using one leg, you're only using half of your transformer, and you're creating a significant imbalanced load and causing there to be a significant amount of neutral current, which is something that normally would naturally balance out. Most of the time when you're using 120 volts, it's actually balancing out against the other circuits that are on the opposite leg, and therefore the amount of load on the neutral stays relatively low most of the time. But if everything was pulling from that one leg, then it wouldn't have any other option but to go back on the neutral. In this particular case, with it being a single 20 amp circuit feeding this panel, I'm really not concerned that this is going to create a significant imbalanced load back on the main panel in the house. The whole idea here is that if they ever need a welder or a big air compressor or something else out here, this cable that's feeding the panel will get replaced with a 4-conductor cable, the 2 hots, neutral, and a ground that will allow it to have a proper 240 volt setup. Until then, these couple of circuit breakers is all that's going to really be needed for the use case of this particular panel. I thought this was going to be a really quick video, but I think I've been talking for quite a while, so if you made it to the end, I really appreciate it a whole bunch. Let me know what your thoughts are on this topic in the comment section below. If you guys want to know more about installing ground bars or why the neutrals and grounds are separated, I'll put those videos here on the screen right now for you to choose from. Thanks so much for watching, and we'll talk to you right over there. So this is really nicely future-proofed so that if at some point they want to bring 240 volts out into this garage, they could do so just by my phone. I'm gonna just, man.